Okay, here we are. Um, so this is going to be a procedure on how to find outliers in one random variable. So a data point which deviates significantly from other data points in the sample is what an outlier is. So finding outliers are great because they do two things. Finding outliers can mean that you've got bad data, or it can mean that you've got a new insight, something that is outside maybe the normal or what was expected. So, in terms of bad data, it can reveal human or experimental error. You can rigorously analyze the origin of the data point deviation. So, you can rigorously analyze the origin of that outlier. This can lead you to question the distribution model used for the data, which the suspected outlier does not fit. Um, and you can report data point error and possibly remove it. But if you identify a data point as being an outlier because of bad data, you always have to report it. Okay. You can't just cherry pick your data and only pick the data that you like and get rid of the data you don't like um, without reporting it. If you do find a data point that doesn't fit, you have to explain why it doesn't fit and um, report that it was removed out of further analysis. Okay. Okay. The other thing, an outlier, and point two is new insight. So this indicates the possible occurrence of maybe new science or new understanding. Um, so in order to mark or identify a data point as being an outlier, we need an outlier boundary, and we can create these outlier boundaries or outlier fences by calculating them using this quantity. So if we take 1.5 times our interquartile range, so 1.5 times the IQR. And so in order to calculate the lower outlier boundary, we take the first quartile and we subtract this quantity of 1.5 times the IQR. So let me kind of show that where this is on a number line. So here we've got a number line where I've identified the first quartile. And so if you take the first quartile and you subtract 1.5 times the IQR, then that moves you to the left in the negative direction to this point. So this is Q1 minus 1.5 times the interquartile range, and this sets the boundary for the lower outlier boundary. So any data points that are on this side of the boundary are considered outliers. Okay, so anything outside the boundary is considered an outlier. Okay, so that's the lower outlier boundary. We also have an upper outlier boundary or an upper fence. And this is going to be the third quartile, which is here, plus 1.5 times the interquartile range. So if we start here at the third quartile and we go in the positive direction, 1.5 times the IQR, then we'll have this upper outlier boundary. And any data points or datums that we have above the upper outlier boundary is considered an outlier. So any data points out here or out here, we can consistently consider that an outlier. Any data points that are here between the two fences, between the two boundaries, are not outliers. Okay, so this is the primary method of setting up boundaries, and anything outside those boundaries we can label as an outlier. Now, that outlier could be bad data or it could be new insight. But the primary take home message here is that we have a consistent method, a consistent procedure that every scientist can follow, that every person can follow, and it will have the same meaning to everyone. Okay. And if you found a data point that was an outlier, you would say, well, this data point was an outlier because of the lower outlier boundary and the upper outlier boundary, and this data point was outside 1.5 times the interquartile range. And that's all you need to say. Okay, so let's look next at an example. Oh, that'll come next. Um, so here on this page, I've just kind of given some more examples of where outliers could be found. Okay, so here, this is an example where no outliers exist. So here's the lower outlier boundary. Here's the upper outlier boundary. And there's no outliers in this example because the minimum and the maximum are both safely inside both boundaries. Okay. Here are some examples where there would be outliers. So outliers exist here. Let's make that go away. Okay. So here's the lower outlier boundary. Here's the upper outlier boundary. And if you had the data such that the minimum, at least the minimum value was on this side of the lower outlier boundary, then you would have an outlier out here. Another way you could have an outlier is here's the lower outlier boundary, here's the upper outlier boundary. And if you've got both a minimum and a maximum value outside of those boundaries, then you've got two outliers, one on each side. And I'm just using kind of the maximum and the minimum. You could have some other data points out here as well, okay? But I'm just saying at the very least, if your maximum value is out here and your minimum value is out here, you're going to have outliers on both sides. And a third alternative is here's your lower outlier boundary, here's your upper outlier boundary, and the maximum is out here past your outlier boundary. So you would have an outlier, but your minimum's okay. All right. So these are the different circumstances where you wouldn't have an outlier, and 3 circumstances where you could have outliers. Okay, so now let's move on to an actual example so you can see how all of this is calculated and kind of gets put together. So here's our random variable x. This is a contextless example. So this isn't really being applied to, blood pressure or number of lollipops given out at a dentist office. Okay, this is just some bare numbers. Okay, so you can see we have numbers that span the range between 1 and 12. So applying one variable stats in the Texas Instruments calculator, or by going into the stats tab under the numworks calculator, we get the following 5-number summary. So we get a minimum of 1, we get a maximum of 12, and then we've got a first quartile of 2, a median of 3, and a third quartile of 4.5. So what we want to do is we want to use this 5-number summary to see if there are any outliers. So from here, we need to calculate the boundary lines, the lower outlier boundary and the upper outlier boundary, which demarcates the data points considered to be outliers or not. So for both boundary, we need to calculate the interquartile range. So the interquartile range is just the third quartile minus the first. And so the third quartile is 4.5. The first quartile is 2. And so 4.5 minus 2 is 2.5. So the interquartile range is 2.5. All right, so next we need to calculate the lower outlier boundary, which is the first quartile minus 1.5 times the IQR. The first quartile is 2 minus 1.5 times the interquartile range, which we calculated to be 2.5. And that comes out to negative 1.75. So let's maybe plot that on a number line. So here's our number line. And the lower outlier boundary is going to be at negative 1.75. So this is one boundary here. Next, let's look at the upper outlier boundary. So that's going to be the third quartile plus 1.5 times the IQR. And that'll be 4.5 plus 1.5 times 2.5. And that's equal to 8.25. So on our number line, we'll label 8.25, and that's going to be our upper outlier boundary. So, taking all of this together, let's look next at our minimum value, which is 1. So 1 would be right about here on the number line. That's our minimum. Our maximum is 12. So 12 would be above 8.25. So that's up here. So this means 12 is going to be an outlier. And so here's the range of our data. So we're not going to have an outlier out here below the lower outlier boundary because our minimum is 1. But we know that at least 12 is going to be an outlier. Do we have any other values in our data set that are greater than 8.25? If we come up here, okay, 12 was the highest. Our next highest number is 6. So 6 is safely on the good side of this upper outlier boundary. So 6 is okay. Right? So the only outlier we have identified is 12. So the data value 12 is identified as an outlier since 12 is greater than our upper outlier boundary. So once an outlier is identified, record it and remove the outlier from the data. So here's our original random variable, our original data set. And so what we're going to do is delete 12 because 12 was our outlier. So we remove it. And now this is our new data set without 12. Okay, so 12 is missing. And now that we've removed a datum from our data set, we have a new data set, and we have to recalculate the 5-number summary. So on this top row, this is before the outlier was removed, and down here is after the outlier was removed. So before and after, we can see the minimum did not change. The first quartile did not change. The second quartile or the median did not change, but the third quartile changed. And of course, the maximum changed because the 12 is gone. All right. So that's why it's necessary to recalculate the 5-number summary once you've removed a number from the data set, because it's going to change the 5-number summary as a consequence of that. All right. Let me know if you have any questions.